Hello everyone. Today we are going to see another important problem in data structure, and this is not it is a classical problem, and it's actually a puzzle, and this puzzle has got some rules. Following these rules you need to solve a problem. Okay, we'll be solving it in simple terms. We'll be seeing this problem using one disk. Before going to the problem, let me introduce what all things we have got here. First, I have got A, B, C. There are three rods A, B, C, and then there are disks. Okay, it will depend upon you. If you want, you can use one disk, two disks, three disks, 4, 5, 6, 7, 8, 9, 10 disks, depending upon the requirement. Let me consider the first requirement. I'll be having one disk. I'll choose only one disk here. Okay, and I should make sure, if you look at the rules of the game, it says that move all the disks from A to C. At present, how many disks I have got in A? I have got one disk. Now my task is to move this disk from A to C, and cannot put larger disk. It is cannot put larger disks over to smaller disk. You will come to know as we solve this problem. Okay. Now, when I have got only one disk here, I have got a direct way of solving it. I'll just lift it here and put it here. Right. This way I have solved the problem in step 1. When I have got disk 1, only one disk, I solved it in only one step. Right. And what was that? Directly move disk 1 from A to C. Right. This was my solution. Right. Now what we will do is we will take two disks. I have got one disk here. I'll take another disk here. Right. Now when you are solving this problem, you need to follow the same things. These are solutions. These are solutions. Here I am going to consider this one as first disk, and this is going to be my second disk. Right. So it will depend upon you. You can take which one is first and second, but here I am considering this is first. Now what I need to do is I can just take the first disk, put it here, then take the second disk. I cannot put it on this because it is going to violate my first rule, because I am putting a bigger disk over smaller disk, which is not feasible. So I'll put it here. Okay, and then after that I'll put it here. Right. So we have solved our problem. Using this B, we are going to transfer all the disks from A to C. Here we took some 3 steps, maybe. We'll check how many steps. When you got two disks, first step, in the first step you will be move disk 1 from, I moved this disk 1 from here to here first, right? So from A to B, and then second step, in second step I moved this disk 2 from A to C, move disk 2 from A to C, and then in third step I moved this disk, first disk, from B to C again. So third step, move disk 1 from B to C. So if you observe here carefully, initially I had this disk here and this disk here, right? And if you want to solve this, what you need to do, just take this. I cannot keep it here because it is going to take more steps. I need to make sure that I'll be having less steps, so I'll be keeping it here. Then take this disk, put it here, second step, take this disk and put it here. This is the third. Right. I hope you understood this problem. Now we'll go for the next one, bit advanced. We'll be taking the third disk also. I got 3 disks now. I need to move these 3 disks to C using this B. So I'll be calling, whenever you are using one rod as a intermediate rod, it can be called as auxiliary rod. Auxiliary rod. It is called as from rod. It is called as to rod. Initially, this is the condition. I need to move these 3 from here to here. This is the problem, right? So what I will do is I'll try to move this one here, okay, and then I'll try to move this one here. I'll move this one here, and then I want to move this. I cannot move this anywhere. I should make sure that one of them is empty. If I lift it and keep it here back, it will be like previous step. So if I keep it on this, it will be violating the rule 1. So I cannot put anywhere. Just I'll make sure that I'll remove it from here and I'll put it on this, and then this one I'll be putting it here, right? Now if you observe, there is a very, in the second case, what is happening, initially we consider this is from rod and this is to rod, but now, and we had 3 disks. Now the problem has reduced. I have got only 2 disks here. You can see I have got 2 disks here. 2 disks. I need to move these 2 disks here using this rod. So in this place, this auxiliary rod is going to become what? From rod. So I'll be writing with a different pen. It will be going to become from rod, right? This is going to become from rod, and this is to rod, right? And this one is auxiliary rod. Auxiliary rod. And how many you need to move? You just consider this doesn't exist as of now. The problem is you need to move from here to here using this one, right? So how many are left now? We are left with only 2, right? Now how we will solve this problem? You will just lift it here, lift this one from here to here and keep, just take this one here and you just move this here, right? And in the end we'll be moving this one here. Thus we have solved, we have moved all the 3 disks from here to here. Fine. And if you look at the steps that we done, actually we have done 7 steps. It took 7 steps to solve this problem. So whenever you have got 3 disks, you will have first step, second step. In this way you will be solving it using, so till 7 steps. You can try writing this, okay. Now our question is, you need to make sure that you are going to write a code for this problem, and even if I enter 10, it should be able to solve this problem within no time. Actually program has got that ability to, that faster ability to solve such questions, okay. Initially it was easy when we had only one disk. 2, it was bit easy. 3, it was little difficult. And if you go for 4, 5, 6 and all, it is going to become very complex. So you just observe, you need to follow these 2 things. Initially we had 3, and then we tried to solve it for 2, and then we solved it for 1. In this way we need to solve for, we need to reduce the number of disks whenever you are solving a problem. Initially 3 we had to move from here to here, we had 3 here, we had to move this from here to here, and later we found that 1 was moved, the last one was moved here, and the remaining were left here, right? And they were supposed to be moved here using this one. So in that case it was n minus 1, right? And at the end we had only 1 here and we had to move it here. This is this case. So we'll see how the code can be written for this one. We'll go to the code. It is very simple code, not too complex, but this is having a recursive function. If you look at this, we have got a Tower of Hanoi. Tower of Hanoi. In this one, we are moving elements from A to C using B. So when you are calling this function, you will be calling this A as from rod, and then you will be calling this C as to rod, and then B as intermediate rod. Okay, and this part is called as a, if you look at this part, this is called as base condition. When n becomes equal to 1, we are going to return. And I have recently made a video and uploaded. You can see that what is the meaning of a recursive function, a function calling itself again and again, right? Now this function, Tower of Hanoi function, is calling itself again here in the line number 9, you can see, but it is calling with one less number than this one, right? And here from rod is from rod only, but the auxiliary rod has changed. You see, auxiliary rod was here initially. Now we are considering we need to move from rod to auxiliary rod. You observe here. Initially what happened? We moved, we had 3 here. We moved these 2 here. That was our duty. We were supposed to move the upper 2 here and then the last one here. So you can see here. This function will help you to do that. We had 3, top 2 were moved here and then the last one was moved here. So these two, for transferring these two, from will be this only and 2 will be this, and then this will be auxiliary. You need to remember this one. So you will see that from 2 is here using auxiliary, means we are transferring from to auxiliary, from A to B using C. So C becomes what? Here C becomes auxiliary. You can see whenever you are passing, C becomes auxiliary, and then 2 becomes, then B becomes 2 rod. It means this is 2 rod. From here we are transferring here the top 2 elements, as I have told you, right? I'll explain that using the animation also. But as of now you understand this. After moving these 2 here, what is your next step? You need to move this one from A to C. So you can see from rod to 2 rod we are moving this one. Fine. And then next we are calling the function again because we have got 2 remaining here and we need to move these 2 here using this one. So what are these 2? This is from, this is from 2, and then this is our auxiliary. That's why you will see again there is a change. We need to move from B, that is auxiliary rod, to C, to rod, using what? This from rod. Using this from rod. This one will be using and will be moving it here. Fine. And when you call this function again and again, this will solve your problem. Let's check whether it works or not. We'll go GCC Tower of Hanoi, right? /A. It will ask number of disks. If I enter 1, it is showing move disk 1 from A to C. As we have written here, you can see here, move disk 1 from A to C, right? Now I'll run it for 2 disks. You can see move disk 1 from A to B. I have move disk 1 from A to B. Then again move disk 2 from A to C. Move disk 2 from A to C, right? And then next move disk 1 from B to C. Move disk 1 from A to B to C, right? And when we'll go for the next one, if you consider 3, just enter. You can see we have got 1, 2, 3, 4, 5, 6, 7. There are 7 steps and we have followed the same steps to move the disk from A to C in case of 3 disks, right? Similarly, this question, now this program is very efficient. Now if I enter 10 disks, you can see it is going to solve it in no time. Just look at this, it has solved so many steps in no time. Still it is like it has solved it in no time, right? I hope you understood. Now we can solve it for 100 steps also, but it is going to take bit time. Now we will see the third one, we'll just see there is a website which will ask you to solve Tower of Hanoi problem. Just move this one here, move this one here, and then we'll I can't move it here now. Just move this one here. This was our third step. This is our fourth step. Just move this one here, move this one here, and then move this one here, right? So we have solved the problem. Now in case of 14 things, see what will happen. Okay, we'll try to solve this. Move this one here, move this one here, then move this one here, then move this one here, move this one here, then move this here, right? And move it here. Now move it here. Now after these many steps, you can observe that you have moved this one here, and now you are remaining with three disk problem. Okay, initially it was four disk problem, now it has become three disk problem. Now how you will be solving this one? You will be solving in the same way that you had solved the initial one. You will be moving it here, right? You will be moving it here, and then you will be moving it here, then you will be moving it here, right? After now it has become two disk problem. You can observe carefully. You need to make sure that you will move it here, you move it here, and then you move it here. So you have solved this in 15 steps. Same way, if you are having a 4 disk problem, you can observe 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. This way you will be able to solve the problem. Okay, thank you.